Hello guys, welcome back to VC Tech. Have you ever wanted to block a specific device from accessing part of your network, but without using a firewall or complicated rules? That's exactly where Standard ACL comes in. In this video, I'll break down Standard ACL in the simplest way, what they are, why they matter, and how to avoid breaking your network by placing them in the wrong spot. With that being said, let's have a bit of a knowledge of what an ACL is. An ACL controls traffic by checking packets against rules and deciding whether to permit or deny the packet. There are two types of ACLs, Standard ACL and Extended ACL. For this tutorial, we'll be talking about Standard ACL, while on the next we'll talk about Extended ACL. A Standard ACL is a network security feature used on a router and a multi-layer switch to allow or deny traffic based only on the source IP address. So why are Standard ACL important? It is important because it controls who can access or leave a network, provide basic security and traffic control. It helps to protect network from unwanted or a compromised device. It acts as a first line of defense in a network. When should we use a Standard ACL? We use Standard ACL only when filtering source IP and when the network design is simple. Rules are read from top to bottom in the access control list, and it is first match wins. If no match, there is always an implicit deny at the end of every ACL statement. The benefit for Standard ACL is it is simple and easy to configure, low resource usage on a router, fast packet filtering, and it is ideal for small network or a lab. So let's start our configuration for Standard ACL on a router. So for today's tutorial, we are going to be using 2 routers, 2 switches, and 6 host device. On each router, I'm going to configure a particular kind of Standard ACL. We have number ACL, as we also have name ACL. So this is number ACL, which we'll be configuring on this router, and we have name ACL here, which we'll be configuring on this router. It serves the same purpose, only name ACL is more easier to configure and to edit compared to the number ACL. So with that being said, I've already assigned IP address to all the host devices as well as the interfaces on the router. Now let's create a routing protocol to enable this host device here to communicate with this host devices over here. As if we try to ping from this device, let's ping the 192.168.2.1 default gateway, and as you can see, destination host is unreachable because we've not configured a routing protocol. Now let's do that on the router before we get into the main topic for today. So we say router OSPF with a process ID of 10, and we want to specify the router ID of 1.1.1. We also want to specify the networks of 192.168.1.0 with the wildcard bit of 0.0.0.255 area 0. We also have the second network of 10.10.10.0 with the wildcard bit of 0.0.0.255 area 0. Now on this router, we've configured the routing protocol, and let's do the same on this second router before we start configuring Standard ACL on the routers. So router OSPF, the process ID of 10, we want to assign a router ID of 1.1.1.2. We also want to specify the networks of 192.168.2.0 with the wildcard bits of 0.0.0.255 area 0. Let's specify the last network 10.10.10.0 the wildcard bit of 0.0.255 area 0. By doing this, guys, we've configured a routing protocol on the router. Let's wait for them to connect. Then we try to ping one more time. Yes, they've connected. Now let's try to ping once again and see what's going to happen. Now we are able to gain connectivity to the default gateway of 2.1 network. Let's ping the host devices. So we have 2.2, which is the server on that network. We can ping 2.2, the server of the network. Let's also ping the host devices of 2.5 and 2.6. And we'll also do the same for this. Let's try to ping with this device. So 192.168.2.2. Let's ping the server. So we are able to ping the server of 2.2. Let's ping 2.5. We are also able to ping 2.5. Let's ping the last device 2.6. And we should be able to gain communication, as we are able to gain communication to 2.5 on this host device, as well as we have for this 2.6. Let's try to ping with this device 192.168.2.6. We are able to ping 2.6. Let's ping 2.5. Yes, we are also able to ping 2.5. Let's do the same on this local area network. Let's try to ping this local area network before we head over and start the configuration of standard ACL. So 192.168.1.1. Let's ping the default gateway. Yes, we are able to ping the default gateway. Let's ping the server. We are also able to ping the server on the network. Let's ping the host devices 5. Let's ping .6. We are also able to ping .6. Let's ping with this device. So ping 192.168.1.5. We are able to ping that host device. Let's also ping the server .2, and we are able to ping .2 server. So this local area network can communicate with this local area network easy because we've not configured standard access control list on either of the router. Now let's get into that now. For this router over here, we are going to configure a standard ACL using number. So how do we do that? We see access list, then we specify the number of 10. For a standard ACL, it uses 1 to 99, as it also uses from 1300 to 1999. That are the numbers that you can use to configure standard ACL. Extended ACL also has its own number. So we'll be using 10 for this ACL that we are about to create. Now we want to specify if we are permitting or denying a host device. So for this local area network, let us deny this server from being reachable, and the server is using 192.168.1.2. so we are going to say deny host 192.168.1.2. then we also want to specify that the other devices or the other IP address in the local area network are allowed to access the internet. So we also say access list 10 permits any. This line over here means that any IP address that is not this first one the first rule that we created, that it should permit them. Remember, ACL reads the rules from top to bottom, so it's going to read that we do not want this device, this host device, to be accessible, and it's going to deny that traffic. Let's also configure a name access list on this router over here. And how do we do that? We say IP access list, then we want to specify what type of access list we are using. For this, we are using standard access list. Then we also want to give it a name. So we'll give it a name. We'll say block. Now we are in the interface of name access control list. So what do we do now? We say permit host 192.168.2.5. we also say permit another host of 192.168.2.6. now lastly, we want to deny access to this server over here. Any other device could be accessible, but this server over here should be denied. Now we are going to say deny host of 192.168.2.2. So by doing this, we've created ACLs on the router. Let's try to ping one more time and see what's going to happen. If we try to ping, we are also going to gain connectivity to the devices from 2.0 network because we've not applied the access control list on the interface. If we also go to this device, remember that we created an ACL on this router denying this host device from being accessible. As we have here, it should deny host of 192.168.1.2, which is this device. Now let's try to ping with this device and see what's going to happen. Of course, we are going to gain connectivity because we've not applied the ACL rule that we created. It is generally recommended to apply the ACL rule that we created, the standard ACL rule we created, close to the destination. This ensures that the traffic is filtered only once it reaches the intended network or interface. So on this router, we are going to apply the ACL rule that we created on this interface gig 0/1. So let's do that. So we say interface gig 0/1 and we say IP access group. We want to specify the number that we gave to that access list that we created, which is 10. And we want to say any network, any traffic that is going inside the network should be checked before it gets to its destination. So by doing this, we've applied the ACL rule that we created on this router. Now the traffic from this host device will be analyzed before they leave the network. Let's also do the same for this local area network, as we are going to apply it also close to the destination, which is on the interface of interface gig 0/1. We want to say IP access group. We want to specify that name that we gave to the ACL that we created, which is block, and we want to say any traffic that is going inside should be analyzed before it gets to the destination. By doing this, guys, we've configured our ACL and also applied it on the interface to allow or deny traffic. Let's try to ping one more time from this local area network. Let's ping 2.5 and see what's going to happen. Yes, we are able to ping 2.5. Let's also try to ping 2.2 and see what's going to happen. Now, we won't be able to ping 2.2 because we've denied any traffic that is going towards 2.2 network. As we are going to be getting request timeout because of the ACL rule that we created on the router. The traffic is being filtered. So trying to ping 2.2 network is going to be denied because we created an ACL rule denying traffic from that host device. We can check our configuration by saying do show run to see the rules that we just created. As you can see, guys, we created a name standard ACL permitting these two host devices and denying this host device. Now, if we try to ping this device over here, we are always going to get that the destination is unreachable or request timeout, because we've already denied traffic going to this local area server and also this local area server, as well as if we try to ping from this device over here to ping 1.6, we are able to gain connectivity because we told the router to permit any network except 1.2. If we also try to ping 1.5, we are also going to gain connectivity. Now let's try to ping 1.2 and see what's going to happen. We are going to get a request timeout because we've blocked any traffic going to that IP address or that server. As if we try to ping from the device, this device over here, remember we said this device has been blocked, it cannot access the internet. So if we try to ping with this server to see if we are going to be able to access the network, that is going to be impossible because we've already denied the traffic, whether it's going in or going out of the network. We've already denied that IP from being reachable. So as you can see, it is showing us destination host unreachable, while previously, as you can see over here, we were able to ping all those devices, but immediately we applied our ACL rule on the interface where it's supposed to be, it is now filtering traffic based on source IP address. And this server over here and also this server over here, they've been denied from accessing the internet. Guys, this is how standard ACL is being configured on a router. If this video helped you understand that, why not smash the like button and subscribe to this channel, because in the next video we are going to be talking about extended ACL, where you get to see it filters source IP, destination IP, port and protocol. Thank you guys, and see you in the next video.